Now we see the problems about isotopes. The problems related to the isotopes. So first see the mass numbers of three isotopes. Already we know the elements are exist in different isotopes. In three isotopes of an element are 10, 12, 4. When their mass numbers, we can treat them as atomic weights units. So their percentage abundance. And if you take some sample of that element, the three isotopes are present in different percentages. First is 80%, 15, then 5% respectively. So we need to find the atomic weight of the element. Means what is the average weight? We need to find out the average atomic weight of that element. So there is already given, these are given atomic weights. But the element exists in these three isotopes which are having the different mass numbers. So we need to find the average atomic weight of that element. So there is a formula to find out the average atomic weight of the element is average atomic weight is M1x1 plus M2x2 plus by 100. Here M indicates the percentage of abundance. X indicates given mass number. It can be treated as given atomic weight. Now the substitute the values in the equation 1. The average atomic weight is, now what is the first isotope's percentage? 80%. What is first isotope's atomic weight? Next, what about the second isotope? 15% with atomic weight 12. So what is the third isotope? 5% with 14. Here and here it is 10.5. So the average atomic weight or the atomic weight of that element will be considered as 10.5. Okay. See the next problem of similar model. Okay. So in this question, the natural occurring boron consists of two isotopes. The earlier problem there were three isotopes per element. If the element is given the boron occurring in two isotopes which are having atomic weights 10.01 and 11.01. But here their percentages are not given. We need to find the percentage of that each isotopes. Means what is the percentage of isotope with 10.01 atomic weight, and what is the percentage of weight of other boron isotope with 11.01 atomic weight. The average atomic weight is given as 10.81. Okay, so we know the formula, the same formula. The average atomic weight equals same M1x1 M2x2 by 100. Here the average atomic weight is given as 10.81, and already we know the M indicates the percentage, X indicates that atomic weight of that particular isotope. Like M means what is percentage? We need to take the find the percentage. Just say M1 means the isotope which is having 10.01. Say it is as X percentage. X percentage into its atomic weight 10.01. So if it is X percentage, Then the second one will be 100 minus X percentage, which is having 11.01 atomic weight. So then on the class multiplication we will get now transfer the X terms here. 10.01x minus 11.01x will get minus 1x. Minus 1x transfer it becomes x and becomes 1101 minus 1081. So that it becomes 20. So the x equal to 20 means here what is the x now? So what is the x? This is the percentage of isotope having 10.01 atomic weight. Therefore, the percentage of isotope of boron with 10.01 atomic weight equals 20%, as we taken it as x. And the remaining one, next boron with 11.01 atomic weight equal to, that is 100 minus x, 80%. Means in that boron sample 10.01 atomic weight unna sample just 20% undi. 11.01 atomic weight unna sample 80% undi. Okay, see the next one. Okay, see the next problem related to isotopes. Here it is given that oxygen consists of isotopes O16, O17, O18, and carbon consists of C12, C13. We need to find how many types of carbon dioxide molecules can be formed, and we need to find what are the different probability of formation of carbon dioxide with help of these two carbon isotopes and these three oxygen isotopes. Now we see with this first we see the carbon dioxide molecules formed with the help of this carbon 12. Now we write the CO2 molecules using this carbon 12 and these three isotopes. So these CO2 molecules, I am writing the CO2 molecules like this, CO2. The involving carbon is carbon 12 isotope. I am taking the first O16. So this is one type of CO2. Next we can change that oxygens with help of this 17, O17, O17. Next again we can use O18. So these are the three CO2 different CO2 molecules in which C12 is present. Oxygens are present in 16, 16, 17, 17, 18, 18 form. And there is also other different forms. C12 with O16 or there may be O17. They may be similar or different. It is also treated as CO2 molecules. Take O17 and O18. Or we can take O16 and also O18. With C12, O16, O17, O18, there is totally 6 CO2 molecules can be possible. By taking only C12. In the similar way, with C13 and O16, O17, O8. There is again possibility of other 6 type of CO2 molecules. Again we write them. C13 again oxygens 16, 16, 17, 17. Oxygen again 18, 18. And we can combine these two isotopes, that is O16, O17 and O17, O18 and O16, O18. So again here also there is a combination. With this combination there is a 6 different molecules, 6 CO2 molecules are present. 6 type of CO2 molecules. Here question is how many types of CO2 molecules are possible with oxygen 3 isotopes, carbon 2 isotopes is using C12 there is 6 isotopes, using C12 there is a 6 type of CO2s, and using carbon 13 there is 6, total 12 types of CO2 molecules are present, in which carbon and oxygen isotopes are different. Okay, take this. So next one, find the mass of 1 mole of electrons. So already we know what is the mass of 1 electron. We know that mass of 1 electron is simply we need to calculate weight, the required mass of 1 mole of electron. We know that 1 molecule, what is the number? 6.023 into 10 power 23. For mass of 6.023 into 10 power 23 electron is equal to how much? We need to calculate this. So that is minus 31. Or we can say that is 54.863 into 10 power 8 kilograms. I'll convert it to grams. 1 kg equals 1000 grams. So now it becomes 10 power 5 grams. So convert it into milligrams. Milligram means again 1000. So that equals 54.863 into 10 power minus 2 milligrams. For this we can write as 0.54863 milligrams. Okay, take it. Okay, see it now. So what will be the difference in the mass number if number of neutrons in it are halved and number of electrons is doubled? Here we need to find the change in, nothing but difference in mass number in O816 if the number of neutrons in it are halved and the number of electrons in it are doubled. So we know all this. The mass number is equal to, always we calculate number of protons and number of neutrons. There is no consideration of number of electrons. So just we need to neglect this change. What is that? The number of electrons are doubled, because we are not at all considering the number of nothing but mass of electrons in the mass number. When total mass number calculate chestappudu, we are not at all considering the mass of electrons. Kabatti ippudu mass number of electron double chesina, triple chesina, dantlo remove chesina, there is no change in the mass number. It depends only on the number of protons and number of neutrons. Means we need to calculate nothing but we need to consider only the change in number of protons and the number of neutrons. Here it is given that only there is a change in the neutrons. The neutrons are halved. Okay, the number of neutrons are halved. Number of protons cannot be changed, so it is also not given. For example, at starting, at initial in void 16, what are the number of protons? 8. So after that, after means after these changes, number of protons are equal to 8. There is nothing change in the protons. Next, initially the number of neutrons. Number of neutrons means here 8 neutrons are present. Here what is the number of neutrons? What is the number of neutrons? Already 8 neutrons are present initially, but here neutron number is halved. Neutron number halved means here 8 neutrons are there, so it becomes 4 neutrons. Now what is the mass number? Therefore mass number equals protons plus neutrons. Here it is 16. No change. Here what is the mass number? After the number of neutrons are halved, its mass becomes 12. Means here mass, what is the difference in the mass? At first its mass is 16. It is changed, decreased to 12. So what is the change in the mass? Change in mass number 2. Means 4 units is decreased. 4 units is decreased. So what will be the difference? So the difference is only 4 units. 4 units decrease. So in terms of percentage, 4 unit decreased. In how many units? Total 16 units. So that becomes 25%. Means due to the halving of the number of neutrons, there is a decrease in the mass number by 25%. Okay, take it. See the next 6th one. So what is the percentage? What is the percentage of deuterium in heavy water? So what is the heavy water? What is the difference in the normal water and heavy water? We know that normal water is H2, in which the hydrogen isotopes are H11, they are protium. So we know that their molecular weight 1 plus 1 and 16, that becomes 18 units or 18 grams. Here it is given that in heavy water, so heavy water means D2O, means the hydrogen isotope present in heavy water is deuterium, that is H12. H12 means in D2O, here the hydrogen mass is only 1, that is the 2 hydrogens are there, 1 plus 1. Here hydrogen mass is 2 units. So that's why 2 deuteriums are there. That is equal to 20 grams. Now we need to find this percentage of deuterium. The percentage of deuterium in this total molecular mass. So the percentage of deuterium equals mass of deuterium by mass of D2O into 100. So what is the mass of deuterium? 2 units are there. 2 units, 2 isotopes are there. 4 total is 20. Is equal to 20%. Means in the heavy water, the percentage of deuterium is 20%. Okay, take it. See the last one. So this is totally different one. Just listen. So calculate the density of fluorine nucleus. Means we have to find, if we take it as a fluorine, we have to calculate the density of that nucleus of fluorine. Supposing that the shape of the nucleus is spherical. So if it is not given, we need to take a spherical shape only. And the radius clue is given 5 to 10 power minus 13. Okay. Minus 13 centimeters. Okay, we know what is the formula for density? Mass by value. Here we need to take a density of nucleus. Density of nucleus means mass of nucleus volume of nucleus. So now we need to know both this mass of nucleus and volume of nucleus. So what is the mass of nucleus? Mass of nucleus is, already we know mass of nucleus is nothing but its mass number, that is given as 19 AMUs. So we need to convert it into grams. Okay, because it is given in centimeters, we must take it the grams. So convert the AMUs into grams. That is 19 into, we know that 1 AMU is equal to 1.66 into 10 to the power of minus 24 grams. 1 AMU is equal to 1.66 into 10 power minus 24 grams. Okay. By what is the volume of nucleus? So volume of nucleus. So what is the shape of nucleus? The shape of the nucleus is nothing but spherical. Spherical shape. By a sphere volume is volume of sphere equal to 4/3 pi r cube. Here volume of the nucleus means nothing but volume of the sphere is 4/3. Pi means 3.14 r cube. So what is the radius is given? 5 into 10 power minus 13 whole cube. So here we get into 1.6 10 power minus 24. Change it there. 3.14. This is 5 cube means 10 to the power of minus 39. So by all these calculations, we get 6 into 10 to the power of 13. 6 into 10 to the power of 13 mass in terms of gram. This in terms of centimeters value, centimeter cube. So gram per centimeter cube. So this is the density of that given nucleus. Okay, take it. Okay.